Quite a bit of oil on it. Okay, let's see what we've got. That's not too bad, that, considering. Okay. That's quite a reasonable finish for a bit of gnarly old plate. Not a bad effort from old Hong Fuck Wom here, so no visible, nothing I can feel anyway in the overlap of the cutter. So quick lick off the other side and we're into the V groove. Let's make a new handle for this one day. I think when we get this radius attachment eventually finished, we'll make a longer handle with a ball on the end of it. That might be its first job, I think. I don't know who cut this one off. I brought this vice on eBay. It came in from the USA. Yeah, cut in half handle, which does come in handy for a speed handle. Okay, so we've got a nice finish on that. There's no the transition there from the overlap of the cutter. There's no definite, nothing I can feel anyway, so that's a good indicator. Your head is trammed in pretty bloody close. So what we do now is we have to cut a V groove down the side there, so it mimics the underside of the tailstock. So when this sits down on the lathe ways, it's all sitting flat level and in its correct position for the radius attachment to mount on the top. So we'll get the V grooves measured up and we'll bring you back. Okay, the next feature on the part we'll do the V groove, which runs across here. Now it's quite critical because the groove, where are we? The dimension of the groove has to be in direct relation to this area, this face here, so the base plate will sit squarely on the latheways. So all we're going to do, it's quite easy, is mimic the underside of the tailstock. Now, what I do first, because we're unsure if these flats on either side of the V groove are the same plane as these flats, because these do nothing. It's all reference from the V groove in relation to this flat plane here. So I'm just going to lay a parallel across the top there. I'm going to push. It feels like there's a little bit of rock in there, but that's Chinese rock. What we can do, put pressure on the parallel. We slide it off that surface. Slide it back on. Try it over here. I mean, I can feel that just as it enters. So that tells me that this plane and these edge here and this edge here are level. So that makes life easy. So all we need to know now is the depth to cut that groove. So we have a piece of round material. That's just a live centre I use in the chuck on the lathe, so it's only soft, but that's fine. As long as your diameter picks up at least half to 3/4 of the way up the V groove. So this is close enough. So set up our parallel, then we'll use a depth mic and we'll get a dimension. So without my arm getting in the way, we'll get a okay, we've got a size here. We've got, what have we got? 1.023. .0225, 1.0225. So I don't know if oh, is it? Where are we gone? Yeah. So when we're cutting our groove, we can just track this measurement. So we'll get the part set up and a cutter set up. I think what we're going to do, I don't want to tilt the head of the machine, so we'll tilt the workpiece and the vise, and we've got a large end mill, so we'll just use the end mill to cut the groove, and that will be good. So when we do that, I'll introduce you to a piece of old technology. Okay, just back from a short break after some pancakes with Canadian maple sauce. That went down well. So we've got our workpiece in the vise here. We need to get it tilted at 45 degrees to enable us to mill the V-groove with an end mill without tilting the head on the machine. There's several ways we can do this, lots of ways actually. So we have a bit of an arsenal of tooling to choose from here. We've got our Moore and Wright bevel square, Moore and Wright engineer square, the old trusty Starrett last word indicator, and a Brown and Sharp square set. So this instance we've used the square butt and clamped it down with a parallel clamp onto the workpiece, and we're just going to indicate along the top of that. So we'll sit this camera back in the stand and we'll run through that procedure. Okay, so as we just explained, we've got the square butt clamped down with a parallel clamp onto the workpiece, and we're going to indicate along the top face. Now, the only drawback with this method is the square butt has to be exactly square to the workpiece. So we use our engineer square and we make sure that is absolutely spot on square to the workpiece. Then we can set our indicator up, travel along. Whoops, we've just fallen into the groove there. Let's move the table across a bit. Okay. The point of the indicator fell into the groove where the scale goes, so okay, we'll reset that. We're on 0. We'll come through to the other side, and we're well within. Okay, we're a thou. Within a thou. That's perfectly acceptable for this job. If it was something high tolerance, you could jiggle that a bit more, but no need in this case. Now, the reason why you have to have the square absolutely parallel, if I angle this a bit, so we're on about a 5-degree angle back now, so we'll reset our 0, and you watch what happens with the indicator. So we'll do a bit of a... There she is, she's travelling down, or travelling uphill, sorry, and uphill all the way. So there you are, if you haven't got that square, there's 9 thou. You could have an error. So that's why you have to have your square perfectly perpendicular to the workpiece. The other method, which is the simple method, we use our Brown and Sharp protractor. We've got that set at a reflex 45 degree. So we hold him. Sometimes you do need an extra pair of hands and not have a camera in front of you. We hold him up against the workpiece as such, and then we can shine a torch behind it to make sure we don't have any light coming through, and then just tap the block up and down accordingly. And lastly, the other method, you could use your Starrett last word. I've got the tip pointed over 90 degrees. You'd set that in your quill on your machine, on a spot, any spot. You'd set your indicator to 0. You set your dials on your machine or your DRO to 0. You travel along a distance, could be 2 inches, 2.5 inches, doesn't matter. You mark that spot on your dials, then you travel down the same amount, 2 inches, 2.5, whatever you travelled that way, you have to travel down the same way. When you have done that, your needle on your last word should still register 0 or the same point you had it on when you started from up there. That's an easy way as well. That method's probably easier if you have a DRO. Okay, so with that being said, we've got this clamped up, we'll tighten it up, and we'll get a milling cutter set up and we'll mill this V-groove. The last thing I have to do is just scribe a line where our centre of the V-groove will be. So we'll do that and get you reset up. Okay, well, as per our drawing, our V-groove starts at a distance of 0.562 from the centre of the V-groove to the end of the workpiece. So from there to there, 562 or 9/16 of an inch. So we'll just set our square to 9/16. I've got to shut one eye to do this. Our measurements on the brown and sharp, they're pretty fine. We'll just get our texter. One of those big fat blue Sharpies. I'll have to invest in one of those one day. So we'll just use our El Cheapo tungsten tip scribe. Actually, it's not that El Cheapo, this. Woodnutfill.com, made in USA by King Tool Incorporated. Well, there you go. We'll just scribe a line across there. That's our reference to start the cut. That's exactly where the corner of the milling cutter will sit. Give this a bit of a horse down. We don't want that to go anywhere. Right, we'll get you set up with a milling cutter and we'll have a crack. Well, as I mentioned earlier, I'm just going to give you a bit of a rundown on some old style milling tooling. I'll still have a bit of it kicking around. This is the stuff that we grew up on back in the day. Now, a lot of you people might have seen these things on eBay. Clarks and spanners. Auto lock. Now, what the hell are these for? I'll show you. Oh, that's the one for the bigger chuck. We have these. A wonderful piece of British engineering from back in the day, and they were good back in the day. Clarkson Auto Lock milling cutter chuck. So how these work is you have the body, which goes up in your spindle. Now the body has a centre in the middle to locate on the centre of the cutter. Then your collet nut and your collet. Now you'll notice, as opposed to an ER, these have a thread up inside the collet there. So that allows you to have an end mill. I'm sure a lot of you people have seen end mills and wonder, why have they got a thread on the end of them? Well, this is exactly why. For these. Now, the major drawback with these is you have to have a set of metric collets and you have to have a set of imperial collets. But this is a 25mm end mill. That's a 1-inch collet. So you can see it's quite loose. Now, the correct collet, 1-inch collet, there's a collet here. This is off a larger version. So it should be a nice snug fit. It should hold there under its own weight. So that's the drawback. You got to have metric and imperial collets for the damn things. So basically how they work, end of the day, your collet goes into your collet nut. They screw together. Okay, you back it off quarter of a turn. Your end mill pokes in. Do it up, you feel it contact that centre. We don't want to have that tight, just back it off a tad. If you don't back it off, you crack the end of the end mill. Then you get your spanner and you tighten it, the nut up. And these are really good. The cutters don't, they never walk out. They can't push up because they're up against that little tip in the end. Absolutely brilliant. But like I say, you've got to carry 2 sets of collets. And you can't use this style of end mill in them. So that's the drawback. So then came along ER40, or the ER, this is an ER40, but the ER series. You can take any size cutter that will fit. So it's just taking the hassle of having metric and imperial collets out of the equation. The scene I was hoping to use this and give this a demo, but because I have a 25mm cutter, which is the cutter I want to use for this job, and a 1-inch collet, I've only just screwed this in here for a demo. It's not good, it won't keep the cutter secured properly as it's supposed to be. So we'll use the ER, bit of current technology. As I've explained for this one before, this is a Mechanica brand, a very high quality one, made in Taiwan. And they're good. Make sure you always have a good quality set of collets, that's half the battle. There's some cheap ass collets around, they're just not worth 2 knobs. This is a set of, these are made by Jacobs, and these are very good. Just a piece of useless information, so let's get our cutter set up and we'll do this V-groove. Okay, so we'll get our groove cut. This is a 25mm cobalt high-speed steel end mill. It's a regrind. We'll see how she goes. So we'll get the corner of the end mill, just touching our scribe line. Okay, we're just on it there. So we'll zero our dial up here. Put the camera in the way again. We'll zero this dial up here, our quill. So our quill movement has to equal our table movement. So if we come down, whatever we come down on the quill, we have to move across on the table to keep us in the centre of the V-groove. So come back 3mm on the table. Lock her off. Come down 3mm on the quill. One, two, 1, 2, have to move the dial again. 3 millimeters. This is a pain in the ass mill. This, it has conversion dials. So on your table travel, it has a metric lead screw, so 1 revolution is 3 millimeters. On this quill, it doesn't equate to any hole divisions after you go 1 revolution. 1 revolution brings it 2.4, 2.52 millimeters, which is, I don't know, it's an Asian thing when they make these machines. So, okay, lock her all off and proceed to do our cut. I'll run a bit of colours on this. Okay, well that went rather well, so we'll take some more cuts and keep on going. Okay, well we better get a couple of measurements here just so we don't overshoot our mark. Hate to do that because if we go too deep then we've got to take a piece off this face here, which is a bit counterproductive. So, okay, we've taken our 2 roughing cuts through on the V-groove, so we've got to get a final dimension now for a finishing cut to bring it to size. So we'll just repeat the process that we used to measure the V-groove in the tailstock. We'll put our centre in again, so hold it down with a parallel clamp. Then we'll get a, trying to lean over the camera here, we can get a dimension exactly where we're going with this thing. You have to be a bit ambidextrous. Okay, so we've got a reading. We've got 1.023, which camera probably won't. Okay, so all we do is we deduct our original measurement that we took on the tailstock of 0.9775 from 1.023, and we come up with a dimension of 0.0455. Okay, so there's our original dimension off the tailstock. That's our new dimension. So we come up with 0.0455. So that's our depth of cut that we have to take. Now, that's a cut that we have to take in a diagonal direction, 45 degrees, because remember we are doing a 90-degree V-groove, hence our plate was set up at 45 degrees. Now, that makes things a lot easier because we're working with triangle. This is Joe Piezinski sort of stuff. This is he's the master at it. Okay, so at the end of the day we have to move this centre down 45.5 thou. And I've got a fly giving me the shits. Got him. Land of flies in Australia. Didn't get him. Okay. So we use a bit of trig here, so we know we can create a triangle out of our movements we have to make. And it's a right angle triangle, 45 degrees and 45 degree angles, 90 degree angle there. So we know our long side, the hypotenuse, side C, is 0.455, so we just need to find out side A and side B. That way we can plot where our cover has to be. So we use a bit of trig, B, which is what we need, side B or side A, it doesn't matter, they're the same, equals C times the cosine of A, which C is our dimension here, which comes out to 0.032. So our sides, we move along 32 thou, and we move our quill down 32 thou, and that will be our new, that will extend this corner down our 45.5 thou, if that makes sense. So we'll try that and see how it goes. Okay, so we've set an indicator up on the other side of our vise. So we just want to track our table and quill movement, and this is the most accurate way to do it on this machine anyway. So we have to move the table 32 thou. I'm only actually going to move 30. So I just want to give myself a little bit of wiggle room here. So we'll move the table across 30. And we have to move the spindle down the same amount, 30, to maintain our 45 degree axis. We'll just pick up a point, any point. So we come down 30. And lock it off. Nice and tight. The table's nice and tight. When I lock the table on and off, it does actually move that spindle dimension. It moves it 1 thou. Okay, so we'll take a cut, then we'll do a measurement and see where we are with this thing. Say that'll bring us pretty close. We may just have to do a spring cut or two just to clean it up. The tool is on. Away we go. Okay. Take a measurement of that, see where we're at. Okay. Okay, we've got 0.9. 98.980. Yeah. 0.980, and we're chasing 0.9775. So we've got a couple of thou to take off it. We might just do a couple of spring passes, see if that. Remember, we did go shy of our 32 thou in the depth, we only went 30. Hoping not to overshoot, which we haven't, so we'll just take a couple of spring pass and see how we go. Okay, well, we'll take another measurement. A bit awkward trying to hold this. But 9775 I think is what we were shooting for, I think on our, yeah, our original. We're about 9778, so we're only about 3/10. Oh, you can't really see that. That's all right. We're only about 3/10 under. So that's good. Good result. So we'll deburr that. Okay, well, let's compare our dimensions. Centre slug back in. So our original .9778, and our new piece, which we've just duplicated, 0.978. So we're 2/10 of a thou out, which is pretty darn good considering the state of old Hong Fuk Wong's slides and ways and idiosyncrasies she has when you lock the quill and that, so we'll call that one a winner. We'll take it over the lathe bed and we'll give it a test fit, shall we? Beautiful. That'll make a really good base for our attachment that we're building. So, well, we had a win with all of that, even with the state of the nation, with the Hong Fuck Wongs slides and idiosyncrasies. When you tighten up the table, the quill moves. That's just the table rocking a bit, so she's a bit out of adjustment. So, but at the end of the day, we had a good win, good result. Everything came up well. So that'll be it for this week, and we'll continue on next week. Thanks for watching. Bye.